So shaft key, for when you design a shaft key, we have to do the calculations associated to its width, breadth, or you can say the thickness of the key and the length of the key. These are the three features which is required to be designed, and it will depend on the shaft diameter. So basically the load which is applied on the key, that is the load transmitted from the motor to the shaft, and the shaft transmits its load, its force on the key, and this key may break or may fail because of the shearing action and because of the crushing action. The two forces, that is the shearing force and the crushing force, that will be exerted on the key, and as a result the key can fail. So what is the actual load which is acting or transmitted on the shaft? First we have to consider that, and then this load which is nothing but the P, which is equal to T into D by 2. So this is the transmitted by the shaft, which is most important, transmitted by the shaft because of the electric current or electric motor which exerts the load on the shaft. That is why we call it transmitted by the shaft. Torque to be transmitted by the shaft. So this is the torque T, which is the load into the D by 2. So P, which is equal to T into D by 2. Then this will be exerted on the key, and this key will have to face the shearing force or shearing stresses. Fs is your shearing stresses, and which will be acting on the area of W into the L, width into the length. So the strength of the key for failure by shearing, P, which is equal to the WL into the Fs. And second is the failure by crushing. So this P load, which is nothing but the crushing stress Fc into the length into the thickness by 2. Now thickness by 2, that is taken because half the key is there in the hub and half the key that is there in the shaft, and that is why we are taking the thickness by 2. Then by equating the different forces in the shearing and crushing, we can able to calculate the ratio of the crushing stress to the shearing stress, which comes as the 2 times the width upon thickness. For a square key, width and the thickness, they are same. So crushing stress upon the shear stress ratio, that will be equal to 2 times. Generally the square key that is used and having the dimensions or the width that is equal to the D by 4. The diameter, shaft diameter का 1/4 है, is the width of a key or thickness of a key. So the allowing shearing or allowing the crushing stress is twice the shearing stress. Then if the length of the key is determined by equating the strength of the key in shear to the strength of the key, strength of the shaft. So strength of the key in shear to the strength of the shaft in shear. So this is nothing but the strength of the shaft in the shear, and this is the strength of the key in the shear. So that is to be equated. तो इक्वल फोर्स ट्रांसमिट हो रहा है शाफ्ट से की में फोर्स ट्रांसमिट हो रहा है shear force, and that is why we have equated that to calculate the width and the length. So width, that is generally taken as the diameter upon 4, W, which is equal to the D by 4. So length, that will be calculated as 1.5 times D, but the actual strength of the shaft, that will be reduced by 25% because we have cut a key weight in the shaft. So the strength of the shaft that is reduced and will remain as Fs into 0.75. So there you can by substituting the length, that will be calculated as 1.2 times the shaft diameter when we have taken into the consideration of the 75% strength of the shaft. Now, are you able to see the numerical? Yes, sir. A steel shaft is used for some operation, is driven by a 25 HP motor which is rotating at 1440 rpm. So motor power, that is the 25 HP motor is used, and its rpm is 1440 rpm. Generally the rpm of the motor is 1500 rpm. Very few motors are there which is having the 3000 rpm. These are the two mostly rpms which are most common, and they are 3000 rpm and 1500 rpm. So around कम ज्यादा थोड़ा सा वैल्यू हो सकता है, but generally it is the 1500 rpm motor, or the rpm of the motor is 3000. So then the extension of the shaft is 7.5 centimeter. The extension of the shaft, that means in length of the key. In this case, the shaft is extended to the 7.5 centimeters, so that at the bottom we will be able to fix a key, and to that portion we are able to fit a hub, which means the blades of the impeller that will be fitted suitably. For that purpose, the extension of the shaft that has been given, and the diameter of the shaft is 4.5 centimeter. The motor pull-out torque is 3.4 times the average full load torque of the motor. Now this is motor pull-out torque is 3.4 times the average full load torque. What it means? The average full load torque and the motor pull-out torque, it is similar that when we switch on our fan, it gets a little jerk in the initial stage. It gets a little jerk initially. Now at this time, the torque which is provided by the motor on the shaft, torque which is provided by the motor on the attached shaft, will be more initially. Once it is in rotation, then it will have a same, or you can say the steady load, steady torque. In running condition, it's the steady torque, but in initial conditions, it is the motor pull out torque, और मोटर का फुल आरपीएम में आने के पहले जो कुछ टॉर्क रहेगा, that is what we have considered the Ks and Kb values. Here that value is 3.4, and the average full load torque of the motor and the shock factor is 2.4. Then the shear strength, which is 550 kgs per centimeter square, while the compressive stresses is 1100 kgs per centimeter square. Now calculate the size of the key and check the shear strength of the key against the normal shear strength of the shaft. So what is the torque that will be exerted by the motor on the shaft? So first we will calculate the full load torque of the motor. मोटर का कितना टॉर्क डेवलप करेगा मोटर, and then we will consider the motor pull out torque, because initially I am having a jerk. So full load torque, that is calculated by HP into 4500 upon 2 pi n. This formula we have already studied in the 12th standard or so. So this torque, which is not equal to the HP into 4500 upon 2 pi into the n. So you will get the HP is 25 HP motor, then n is in the RPM, 1440 RPM is there, and to convert it into the centimeter, multiplied by 100. So 1243 kg centimeter is the full load torque. While the motor pull-out torque, that will be the 3.4 times the full load torque. That is what it has been mentioned. The motor pull-out torque is 3.4 times the average full load torque of the motor, and that is why this is the motor pull out torque, which is equal to 3.4 times the average full load torque of the motor. Sorry, that comes as 4227.6 kg centimeter. Then coming to the shear stress values, the compressive strength is given and shear stress is given, but the shock factor that is given is 2.4. So this allowable shear stresses, that will be reduced, that is 550 divided by 2.4, which is equal to 230 kgs per centimeter square, and allowable crushing stresses, that is 1100 upon 2.4, that comes as the 460 kgs per centimeter square. The square key that is adapted in this case, generally it's a square key that is preferred. Also the extension of the shaft, that is nothing but the length of the key, that is given as 7.5 centimeters. So we have to calculate the width of the shaft in this case. So width of the key, that can be calculated as Fs into 2T into dW into the L, which is equal to the shear stresses, the area into the shear stress, area of the key, that is W into the L, into the shear stresses into the area, which is equal to the torque because of the shaft. So two stresses, that is one is because of the shear stress and the area. This is equated with the torque exerted by the motor. So here W, that comes as 1.09. When it's a cross-sectional key, that is 1.09 into 1.09 centimeter. So length and the width, that is calculated. Now also the calculate the size of the key and check the shear strength of the key against the normal shear strength of the shaft, that is also to be calculated. So strength of the shaft with the key upon the strength of the shaft without key, which is equal to the K. So K is the ratio of the strength of the shaft with key and strength of the shaft without key, which is considered to be as a 75%. So this is equal to the K into pi d cube upon 16 into the Fs. And where K, that is calculated by using this formula, K minus 0.2 W upon D minus 1.1 times the T upon 2 into the upon the D. So this you have to remember, and that comes as the 0.82. So K ratio, that comes as the 0.82. Now applying the strength, shear strength of the key. So area into the Fs into the D by 2. So the same formula, this formula is manipulated here. WL into the Fs into the d by 2, which is nothing but the torque T, upon the strength of the shaft, shear strength of the shaft, which is equal to the so T, which is equal to the pi d cube upon 16 into the Fs into the K, the ratio. So that comes as 1.15. So it is suitable or sufficient to have this diameter